Welcome to the LabVIEW FPGA self-paced online training course. By the end of this module, you'll be able to describe the benefits of FPGA technology. Here we have the roadmap for this course. So in Lesson 1, we'll start off by just having a quick introduction to FPGA technology in general and also LabVIEW FPGA. In Lesson 2, we'll start getting started with the LabVIEW FPGA environment. So we'll talk about setting up your hardware and just getting started. And Lesson 3, we're going to dive into the LabVIEW FPGA development environment a little more and just talk about general programming principles. In Lesson 4, we'll talk about using I/O with your FPGA. Lesson 5 will continue by talking about how to time your FPGA VI. In Lesson 6, we'll talk about executing code within a single clock cycle. And then in Lesson 7, we'll talk about signal processing. So here we'll talk about how do you implement algorithms on your FPGA and best practices for that. Lesson 8, we'll talk about how to share data on your FPGA between multiple loops. In Lesson 9, we'll talk about how to synchronize FPGA loops and also I/O if necessary. In Lesson 10, we'll talk about modular programming. So here we'll talk about best practices for using sub-VIs on FPGAs. In Lesson 11, we're going to bring everything together and we're going to talk about how do you communicate between your FPGA that you've written and also the host VI. So here we have the course goals. So this course is going to prepare you how to select and configure reconfigurable I/O or RIO hardware. We'll also talk about how to create, compile, and download LabVIEW FPGA VI onto your NI RIO hardware. We'll talk about performing measurements, both analog and digital, and doing different types of I/O with your FPGA. We'll also talk about creating a host computer program so that you can interact with your FPGA VIs from another computer. We'll also talk about controlling timing, synchronizing operations, and also implementing signal processing algorithms on your FPGA. We'll also talk about designing and implementing applications using your LabVIEW FPGA module. So we'll talk about how to use the LabVIEW FPGA environment to create FPGA applications. In Lesson 1, we have the introduction to the LabVIEW FPGA. So we'll start off by having an introduction to FPGA technology in general. We'll also talk about the different components of a LabVIEW FPGA system. We'll compare it with a DAC-MX system so you can see the differences between the two. And we'll finish off by giving a couple examples of LabVIEW FPGA applications. So what is an FPGA? An FPGA is a field programmable gate array. One way of thinking about it is it's a programmable silicon chip. So what you can do is on software you can define the functionality of what you want that FPGA to execute, and once you've done that, you can send that to your FPGA, and then the FPGA will actually rewire its own hardware to implement that functionality that you defined in software. One awesome thing about FPGAs is it allows the user to define and redefine functionality. So you can update the functionality of the hardware on that FPGA chip. So how exactly does an FPGA work? So you can define the functionality of your FPGA through software. But if we take a look at the FPGA chip, let's take a look at some hardware components that are on there. So on your FPGA chip, one thing you see is logic blocks. The logic blocks, those are the things that are able to perform the logic functions. So for example, calculations, processing, and things like that. Another thing that's on this chip is programmable interconnects. And what these do is they are able to connect different logic blocks together to implement your functionality. You also see I/O blocks on there. So the programmable interconnects can also connect things to I/O blocks, and that's the way of an FPGA being able to get input and output signals into and out of the FPGA. So as you can see, the FPGA, there's no operating system on it. The FPGA is just hardware. So when you're implementing something on the FPGA, it's going to be very reliable and very fast. When is an FPGA used? So because FPGA is implemented in hardware and it's essentially custom hardware, it's going to have very fast I/O response times and specialized functionality. So you can create customized triggers, customized protocols, and things like that. Another way of creating custom hardware is an ASIC, which is an application-specific integrated circuit. However, if people go in this route, there's going to be a high price and a long time to develop it. So there's a lot of overhead that goes into creating an ASIC. You'll have to design the chip, then you have to send it off to a fabrication facility. And this could make sense if you're doing if you're trying to create thousands of chips. However, sometimes you want to be able to rapidly prototype, and you want to be able to skip the fabrication process of an ASIC design. And that's where you can use an FPGA. And designing an FPGA, you're going to have much faster prototyping times because you don't have to go through the fabrication process. You'll also be able to implement custom functionality with the reliability of dedicated deterministic hardware. Because an FPGA is implemented on hardware, it's going to be very reliable. Also, another thing that is really beneficial with FPGAs is it's field upgradable after deployment. If you have an ASIC, once you've created it, you're not going to be able to change its functionality. However, with an FPGA, what you can do is if you implement an FPGA with a certain algorithm on it, then later on, if you need to update that algorithm, you can go ahead and take that FPGA and then just reprogram it to have that new algorithm on your hardware. So what are the benefits of an FPGA? So one, it's flexibility. You can reconfigure it through software and upgrade it at any moment. Also, you're going to have true parallel processing. Because it's implemented in hardware, you can have simultaneous parallel circuits executing at the same time. There is no CPU to share because there is no OS. Also, it's going to be very high performance. You're going to get very fast speeds. Also, it's going to be reliable, just like we talked about earlier. And you can also use it to offload processing from your CPU. If your host is using algorithms that are very CPU intensive and you want to offload some of that, you can place that onto the FPGA chip instead. Also, again, you can save costs by using an FPGA because you don't have to go through the high cost of developing an ASIC. In this section, I gave you a really quick overview of FPGA technology. If you want to find out more about FPGA technology and the benefits of it, you can go to ni.com/FPGA for more detailed information.